Hello student, the question says a uniform thin rope of length 12 meters and mass 6 kg hangs vertically from a rigid support and block of mass 2 kg is attached at free end. A transverse short wave train of length 6 centimeter is produced at the lower end of the rope. What is the wavelength of this wave train in centimeters when it reaches the top of the rope? So as given, this is 3, 6, 12 and 9. This is a JEE Mains 2020 question. So let us see how are we supposed to solve this. There is a rope given and mass of the rope is given as 6 kg. And there is a mass that is hanging from it and it is 2 kg. Now the question is, what is the requirement for this mass of this rope? Since this rope is not massless and it has a mass, the tension would be different at different points in the rope. Like example, if I select a point A here, this would have one tension. If I select point B here, it would have different tension. So at different points of the rope, it will have different tension. Now the question is, how do you find the tension? Like example, if I want tension at A, it is simply total mass below it into G. Total mass below it into G. This will easily help you to determine the tension. We can derive this, how we got this, but it is better if you remember it, like it would be total mass below it into G. Like example, if I ask you, what is the tension at the lowest point, like here, at the starting point, like this is the starting point. And if you want tension at the starting point, the mass below it, there is no rope at all below this. The only thing that is there is this external mass 2 kg. So tension at this starting point, like I will call it as, let me call this as A. Tension at A is mass below it is 2 into G. So the tension here is 2G. So let us assume G as 10 and we'll get it as 20, or else I'll just leave it as 2 into G. Now suppose if I take a midpoint, even though it is not necessary for this problem. So if I take a midpoint, if I want tension at this midpoint, mass below it into G. We already have 2 kg. This total rope mass is 6 kg. What will be the mass of half of this rope? If the total mass is 6 kg, the rope, half rope mass would be 3 kg. So we have 3 kg rope below this midpoint and we have a 2 kg mass hanging. So total mass below the midpoint is 5 kg. So we can write 5 into G. And let us take the highest point now. So the final point, that is the highest point, this point which is useful to solve the problem. Because as the author says, we want the wavelength when it reaches the topmost point. Like let us say this is the topmost point. Let me call that point as B. So if you want T at B, mass below it, the entire rope is hanging below this point only. Since the entire rope is hanging below this point, so we have 6 kg mass and also extra 2 kg that is hanging into G. So it would become 8 into G. So we know tension at A is 2G, tension at B is 8G. What if somebody says, I want to find what is the tension at 2-meter height from the bottom. If you want 2-meter height from the bottom, then you have to use mass per unit length. And then you have to find what is the mass of only this segment of the wire and you have to multiply with G. Okay, now I got tension at the lowest point. So this is the lowest point and I'm calling it as A, and the highest point and I'm calling it as B. So we got tension as 2G and here as 8G. Now the question is, what happens when there is a change in tension? If you create a wave, let us assume we have created a small wave segment here. And when this wave train, when it travels from one place to another place, as it is traveling from one place to another place, if the tension changes, we know velocity of a wave in a rope is root T by mu. T is the tension at that location and mu is linear mass density. Linear mass density. It also means mass per unit length. In simple terms, the mass of rope divided by length of the rope. In the question, if you read it carefully, he has given a uniform thin rope. Since it is a uniform thin rope, so by this statement that it's a uniform thin rope, we can say this mu is constant. So we can say V rope equals to root T by mu. Since it is uniform thin rope, it implies that mu value is constant. Since the value of mu is constant, we can write velocity of the rope is proportional to root t. Remember, we can only use this proportionality symbol when all the other terms in the formula are constant, or else it will create a confusion. So velocity of a rope is proportional to root t. Once we have velocity of a rope is proportional to root t, so as the tension changes, if the tension increases, the speed with which this wave is traveling also increases. Initially, it could be traveling slowly, but as the tension increases, it will travel very quickly. Now, what happens when the velocity of the wave, like velocity of a wave increases? We know velocity of a wave can be written as frequency into wavelength, and we can say it is proportional to root t. And remember, frequency does not change with medium. So frequency equals to constant. So finally, this entire thing becomes wavelength proportional to root t. This is how wavelength changes depending upon this t value. Now I can indirectly say that as it goes up, na, like this wavelength will become larger and larger. So originally, if it starts like this, as it is traveling upward, so this wavelength would keep on increasing. I cannot demonstrate, I can not do both the things simultaneously. So, but I hope you understood the picture. It will slowly travel upwards. At the same time, it will start to become bigger and bigger also. So both would happen simultaneously. We have to tell the wavelength at the topmost point on the rope. So let us continue. We got lambda is proportional to C. So lambda at the top divided by lambda at bottom is equals to root T at the top. T at the top, I have called it as B, and T at the bottom, so I call it as A, root TA. So root TB, we got it as 8G and TA as 2G. So root 8G by root 2G. So you'll get root 4 because 2 would cancel 4 times. So root 4, which is 2. And lambda at the top is simply lambda at bottom into 2. And in the question, it is given the wavelength of the bottom of part of the rope is 6 centimeter into 2. So it would be total 12 centimeters. So that would be the wavelength. So indirectly speaking, suppose if this is the wavelength, by the time it reaches the top, its length would become almost double. So it will length would become double by the time it reaches the topmost point. I hope you understood how I have solved. The most important thing in this is that first you should know how to find tension in a rope. If you want tension in a uniform rope which has a mass, you simply need to find what is the mass below it into G. That is very important. Mass below it into G. Using that, we can tell what is the mass at the various locations. And as the tension keeps on changing, velocity of the rope changes, due to which the wavelength also changes. In this way, we'll substitute all the required things and we got our answer. Hope you understood how I have solved.